Good evening to one and all. Welcome to Embedded TestCon, a Menlo Park initiative. This is Srilata, Senior Application Engineer at Menlo Park. After the sessions we had early this morning, moving ahead to our next session, which is a case study that would be presented by Mr. John Mills, CEO, SimuQuest. As part of the sessions, Mr. John will highlight on SimuQuest involvement in one of their prospective customers' issue and how SimuQuest Engine Control Applications along with SimuQuest proprietary tools such as UniFi, Quantiphi and Enginuity helped in rectifying the real-time problems in that project. The presenter for current session, John Mills, heads SimuQuest as President and CEO. John has worked for many automotive companies like Ford, GM, Hyundai and also Motorola in control systems and engineering management for powertrain and body control applications. Menlo Park Technologies is the leading provider of embedded hardware and software products to automotive, automation and aerospace industries across the globe. Our engineers can advise you on the best product set to suit your technical and business needs, and we offer product configuration and bundling of hardware and software solutions for hassle-free product development.
Thank you for joining me today. At SimuQuest, we care about innovation as well as fast and safe development of electronics. We've seen good results with past customers, but until now you've had to take our word for it, as we did not have customer permission to use their data. However, today I'm excited to tell you that Mahindra has allowed us to share their actual results across several vehicle programs that used our products. Here is the flow of my presentation today. A little background on how we got involved with Mahindra, the challenges that Mahindra faced, how SimuQuest products helped Mahindra meet these challenges, and finally, the exciting results shared by Mahindra. Let's dive in, starting with the partnership between SimuQuest and Mahindra. In 2016, SimuQuest began supporting Mahindra North America with its ambitious plans to develop diesel, gasoline, and hybrid electric vehicles. There was a philosophical alignment around the need for collaborative innovation. Mahindra decided to develop their own controls and electronics with help from SimuQuest, rather than being dependent on Tier 1 suppliers for these systems. The president of Mahindra stated, "Without having our own technology and products, one will never become a true manufacturing nation." This goal drove the decision for Mahindra to develop their own systems and their own intellectual property. Let's first discuss the main challenges that Mahindra faced. And to help with this, Mahindra has kindly let us use some of their original slides. Any slide marked with the red Mahindra logo is directly from their own summary presentation of these programs. Mahindra wanted to innovate and own the intellectual property for technologies they deem critical, such as powertrain control, and wanted to reduce the cost and timing of development. This Mahindra slide further explains the motivation to reduce the dependency on Tier 1 suppliers. This dependency restricted innovation, resulted in significant communication overhead and drawn-out negotiations, and high costs for software changes. A change to the application software might be anywhere between $500,000 and $2 million and take several months to implement. Very simple changes to a calibration parameter, such as tire size or maximum speed limit, might cost $30,000 and take several weeks. Some of the other big challenges included a compressed timeline of less than 24 months from concept to in-vehicle validation for several overlapping programs, building new teams of engineers to support these programs, and only a few of the engineers had previously used the MathWorks tools, and the team was incomplete at the start. A model-based process had to be developed and agreed to. Since Mahindra would be replacing previously outsourced systems with their own, they had to develop everything from scratch: requirements, design, controls, diagnostics, etc. And a micro had not yet been selected, and therefore no platform software existed, device drivers, etc. In short, this seemed like an insurmountable set of challenges. And to boot, the Tier 1 suppliers put some pressure on Mahindra, stating, "Any one of these programs is going to take you at least 10 years to develop, even with an army of engineers." Even though Mahindra had some unique challenges, they ultimately relate to the same set of challenges that most, if not all, companies face. Getting to market faster than their competitors with a differentiated product, also known as making money. Staying within budget during development, or, as is more often the case, not going wildly over budget, and to reduce the risk of software defects that could have disastrous consequences, resulting in expensive recalls, warranty costs, vehicle safety problems, and legal costs. Now let's take a look at how SimuQuest worked with Mahindra to provide solutions to these challenges. First, SimuQuest provided baseline system models in Simulink and Stateflow for the vehicles and with the different engine types. The model schematic shown here is for the hybrid electric vehicle. These models included baseline control strategies, plant models for the vehicles, and baseline system tests. Each of these systems could be simulated for model-in-the-loop testing, so that Mahindra could hit the ground running with each of these programs. The system models used engine and vehicle plant models from libraries provided with SimuQuest's Engine and Vehicle Modeling Package, Enginuity. These controls-oriented plant models were eventually calibrated to closely represent the real vehicle and engine for each program. Then there was the problem of not having a micro-selected or any platform software, such as device drivers and operating system. To solve this, Mahindra leveraged SimuQuest's Quantiphi tool. Quantiphi enables microcontroller peripherals to be easily configured without ever having to read a datasheet, provides a block set to connect to the micro's peripherals in Simulink, and auto-generates fully tested, production-ready device driver code. In partnership with Renesas, SimuQuest had developed a version of Quantiphi to support Renesas E1X powertrain family of micros, and also a Quantiphi extension to support the Renesas Rapid Prototyping ECU shown on this slide. Mahindra used this ECU and would later customize it for production for each of their programs. Even though these baseline models would be a big help, we knew there were still some big challenges remaining. Mahindra had to develop and evolve their own development process. To help them, SimuQuest provided model-based process training based on MathWorks and SimuQuest tools. You've likely seen depictions of this process, with a flow from requirements to on-hardware and in-vehicle testing. Of course, it has to be stated that the first main benefit of model-based design is the ability to test in simulation and iteratively evolve models and requirements, building confidence in correct behavior before having to develop software and to manually integrate and test on hardware, which is very expensive in dollars and time. And another main benefit is the ability to auto-generate code that can be tested on hardware using processor-in-the-loop and comparing results back-to-back with model-in-the-loop tests. At SimuQuest, we prefer to think of this process as a continuous, iterative cycle of development, starting simple, rapidly evolving with virtual iterations, and later iterations that include code generation and automated testing on hardware. It would be nice if all that I have described so far were sufficient to enable Mahindra to succeed. But even though many companies that have adopted a model-based process have improved development efficiency and quality, I have to tell you that a very big problem remains. And this problem would certainly have prevented Mahindra from meeting their compressed timelines. It has to do with consistency. The importance of having the process and discipline to develop good requirements and tests is generally well understood. But note the light blue section of this cycle that follows requirements. The elephant in the room is how to keep all artifacts of development consistent, and especially the overall structure or architecture and its interfaces and data, as individuals and teams collaboratively develop a complex system. Referring to our earlier hybrid system model schematic, we see that each part of the subsystems can be represented as a functional decomposition of its architecture. This depiction, of course, is a gross oversimplification. The decomposition of the controls ultimately results in hundreds of features that are themselves complex and that implement specific functional requirements. A system like this will have tens of thousands of data items, including interface variables and calibration parameters, each with several attributes. The possible permutations of structure and data within these systems is virtually infinite. To further emphasize this point, here is a slide presented by Ford at a MathWorks conference a few years ago, illustrating the problem of software complexity across Ford's engine programs. They have about 35 applications, each with about 150 features, engineered by 200 developers on different continents, and with something like 10,000 signals and 30,000 calibration parameters per application. And each application, together with its variants and data, changing over the course of these multi-year programs. Let's examine the problem to see how it relates to Mahindra's challenges. As a system evolves, how is the development of its architecture, along with its interfaces and data, maintained in a consistent manner? Today, these items are typically managed with documents, spreadsheets, scripts, or in-house solutions that are manually developed and maintained. These manual processes pose a huge risk of introducing errors along every step of the way, making collaboration difficult. At some point, each feature has to be integrated with the rest of the system. This integration usually involves a time-consuming manual effort that is itself error-prone. And when we do create and test the integrated model, finding errors during the testing process slows things down even more. In all of this, each time inconsistency occurs and isn't immediately corrected, there is the risk that it scales throughout the system, costing more time and more effort to resolve. Here we see the problem expressed as an increasing cost of change. As complexity increases over time, system requirements, design requirements, architectures, scheduling, feature designs, feature, plant, and integrated models, interface variables, calibrations, tests, etc. There are just too many things to manually keep track of. To keep consistent, technical debt grows over time. Efforts to keep all of these artifacts consistent continue to become more and more difficult, and therefore the time and cost required to resolve each change increases. This makes embracing change impossible. That is, it makes innovation impossible without unacceptable costs and delays. So we have a dilemma. If this is true, how would Mahindra's challenges be met? How would they achieve a compressed timeline while allowing innovation of their own intellectual property for controls and diagnostics? And how would they do this without serious risk of software defects? So this leads to another important realization. Even with a good requirements-driven, model-based process, using powerful tools like Simulink, Embedded Coder, Quantiphi and Enginuity, a good set of baseline models that simulate, there is a huge problem of inconsistency when collaboratively developing these systems. And this makes it impossible to simultaneously meet a compressed timeline and to innovate and be completely safe. Something has to give. Either be very methodical and severely restrict innovation and creativity, or take a big risk that could have disastrous consequences. Either way, the result is invariably very stressed and overworked teams of people. But does this have to be the case? Do we have a choice? Can we achieve absolute consistency even as these systems, teams, and processes evolve over time, with the goal of embracing change? To address the competing interests of developing with speed, innovation, and safety all in mind, absolute consistency is required and can be achieved. SimuQuest has been working closely with automotive OEMs over the last decade, developing and evolving a product called UniFi to address this complexity challenge and to provide a mechanism to achieve absolute consistency. UniFi provides intelligent, centralized management with built-in and custom rule checking to ensure absolute consistency of the system and everything within it. What does this mean? All the core artifacts of development are centrally managed and kept consistent, such as architecture, models, interfaces, and data. UniFi continuously checks for errors, inconsistencies, and rule violations in real time as systems, development teams, and processes evolve. As engineers collaboratively develop, there is a single source of truth for every artifact within the system that alerts users to errors and inconsistencies the moment they occur. Seamless integration of UniFi with other tools is also important. The goal in general and for Mahindra is to eliminate any manual error-prone steps in the development process. A seamless integration with MATLAB and Simulink is imperative. With this integration, developers can import existing Simulink model architectures into UniFi. Then, UniFi's automated rule checking enables any issues to be quickly resolved to guarantee absolute consistency. Probably the most important aspect of the integration with Simulink is that developers can at any time automatically generate error-free integrated system models. And all of this is supported with constant automated testing of the latest version of the system through continuous integration. Now let's discuss UniFi's tie-in with continuous integration. Imagine a scenario where an engineer changes an implementation that modifies the interface of a subsystem in their project. In this case, the integrated model that references this implementation may no longer work. As this system grows and complexity increases, the problem scales. If I'm a developer, I don't want to manually create a new integrated model each time I make a change, even if I do have UniFi's Model Creation Assistant available to simplify this process. Instead, I can leverage UniFi's Java API and configure a continuous integration environment. In this case, I'm using Jenkins as an example. Now, every time a change is made, a new integrated model is automatically created and thoroughly tested behind the scenes. This provides immediate visibility into test results and the downstream consequences of specific development efforts. If there are any issues with the latest version of the integrated model, a developer can easily identify the changes that led to the errors and resolve them, or, if needed, revert to a previous working version of the model that exists in version control. Like other organizations, Mahindra faced the problem of how to know that they were using the most recent working version of the hundreds of feature and plant models that make up their system. Through the use of UniFi and continuous integration, now, anytime one of Mahindra's developers made a change to any of their models or algorithms, the entire team would almost immediately receive test results, allowing them to feel confident that they were always working with the latest, absolutely consistent version of the integrated system. There is more than I can get into for this case study as it pertains to UniFi's capabilities and intelligence. But I at least want to stress the importance of the UniFi Lifeguard. This is an example of the intelligence that is constantly running in the background. There are hundreds of built-in rules and checks for consistency. Anytime a change violates UniFi's built-in rules, users are immediately alerted and the issue can be resolved. In many cases, there is an option to automatically mitigate the issue. However, you may ask the question, how can UniFi possibly satisfy all the rules that are specific to my system? To address this, we added the capability to create custom rules. As the system evolves, a new custom rule is added each time a new type of issue is encountered. Once this custom rule is created, it is reused from that point forward in the current project and in any future projects, so that once resolved, this issue does not reoccur. Leveraging UniFi's centralized management with automated rule-based intelligence, along with integrations such as those described, enabled Mahindra's success. Together, SimuQuest and Mahindra put in place an iterative and agile process to rapidly develop while embracing change and innovation. Now that we've discussed the solutions we provided to Mahindra, let's take a look at what this really meant to them and what this enabled them to achieve, despite all of their initial challenges. As mentioned earlier, Mahindra has kindly allowed us to share some of the results that they presented internally. Here, they describe some of the benefits that they achieved through the use of SimuQuest tools and processes. These slides were created to recommend the adoption of SimuQuest Solutions by the greater Mahindra organization. In terms of resource management, Mahindra is now able to develop complex systems with small, mostly self-managing and agile teams of developers. Also, Mahindra is now able to embrace change. Through SimuQuest Solutions, Mahindra can maintain flexibility and can easily support innovative efforts, without risking an impact to speed and quality. Continuous integration with system models has also been identified as a key enabler for embracing change, as Mahindra is now able to welcome required modifications, even as last-minute requests. And they've been able to add many exciting features, and now own all the developed intellectual property. From a security perspective, this has also reduced leaks of developed IP, program information, and development progress. And this slide shows Mahindra's engine program timelines, with confidential program and specific dates removed. First, a PFI concept was demonstrated within 6 months. This was quickly followed by a gasoline direct inject engine control application that was developed in about 20 months from concept to in-vehicle and OBD validation. In parallel to this effort, a diesel engine control application, shown as TDI, was developed to vehicle and emissions testing in less than 18 months. These were all developed by the same team of engineers. And as you can see, the SIDI and diesel programs were developed in parallel. By reusing these systems, the team estimates that it completed new programs from concept to vehicle prove-out in 8 to 10 months. This was for several overlapping programs, including the hybrid vehicle program, which is not shown on this slide. In contrast, OEM programs typically take 3 or more years, with many tens, if not hundreds, of engineers involved. And that's when starting with a largely reusable control and diagnostic strategy, and software from previous programs. In this example, Mahindra developed their own intellectual property, starting with a clean slate and with about 10 engineers total for all of these programs. It's important to acknowledge that the planned TDI project at the bottom of this table is now expected to be completed in a greatly reduced time period of about 6 months, because Mahindra will be able to reuse the process and all of the IP they developed. In terms of quantifiable results, this next slide speaks for itself. It used to take 12 weeks to kick off a new program. Now it takes 3. Previously, Mahindra had the capacity to support 1 program at a time. Now they are able to satisfy the development of 5 engine programs in parallel. And most importantly, making even minor changes used to take about 3 weeks. The time required to make even more complex changes now takes about 1 day. Instead of dependence on suppliers, Mahindra now has complete freedom to develop and innovate their own controls. Development is faster, which has allowed them to also deploy new control features for performance and drivability improvement that they would otherwise not have had time for. They've been able to integrate these powertrain controls with other systems, such as for ADAS and traction control. They were easily able to support changes to requirements and features mid-cycle. They've developed a lot of IP, including numerous new and well-tested control and diagnostic algorithms. As mentioned earlier, changes to the application software used to cost between $500,000 and $2 million and could take several months to implement. Even for simple changes, about $30,000 in several weeks would have been required to change parameters such as maximum speed limit. Now their costs have dramatically reduced. They can satisfy these same changes with agility. But their main costs have been minimized to product licensing and server costs, along with a cost of 3 to 5 engineers per program. Here is a summary and a nice picture of the ECU that Mahindra developed to support all of these engine programs, as well as the hybrid vehicle program. Again, here, Mahindra reiterates that they can accommodate changes in as little as 24 hours with the process and tools that we have provided. And now they can leverage this system for many other applications that they will develop in the future. And here is a quote directly from Mahindra's hybrid vehicle team that summarizes the solutions and benefits they received through our partnership. SimuQuest products were invaluable during an ultra-compressed prototype vehicle build project. The quote goes on to say, instead of a large software development team and conventional development processes, 2 engineers working with SimuQuest tools, UniFi and Quantiphi, collaborated in creating custom vehicle supervisory controller software to interface between and manage the powertrain ECUs, the body and chassis controls, passive entry and keyless ignition module, instrument cluster, and HVAC system. The vehicle controller was then additionally expanded so SimuQuest tools could be used to quickly develop software to manage a stop-start powertrain version as well as the hybrid powertrain version that followed. I'd now like to very briefly summarize this case study presentation. Earlier, I explained how technical debt and escalating risk grow over time. Efforts to keep all of the artifacts of development consistent continues to become more and more difficult, and therefore the time and cost to make any changes increases. At Mahindra, the team, the process, and the hybrid and engine control systems were all evolving in parallel. This is always true, but even more so for Mahindra, since they started with a clean slate on these programs. So how does this curve change when deploying UniFi to centrally manage the model-based development? Over time, the cost per change decreases. Why? UniFi enables parallel evolutionary processes. UniFi automatically ensures that the structure and its interfaces, etc., remain consistent. New rules are being added all the time. Anytime a team member finds an issue, a rule is created that is used from that point forward, so that these types of issues do not reoccur on this or any other program. The single source of truth and automated checking and fixing of issues within the system frees up engineers to focus on innovating their IP, that is, the control and diagnostic algorithms, their requirements, use cases, and tests. There is also an important consequential and serendipitous benefit. The engineers get to really engineer, to focus on implementing algorithms and to innovate, to collaborate efficiently, and to enjoy what they do. With automated intelligence and centralized management, Mahindra was able to use an agile, model-based process in order to get to market fast, while also embracing change, significantly reducing costs, and preventing software defects. It is hard to quantify the real value to Mahindra. They were complete more than 1 year ahead of typical program timing, with a completely new team and starting from scratch. New innovations that they had never had with off-the-shelf systems, getting to market early with a great product, an aligned team in terms of process and agility that knows how to innovate, confidence in not having to worry about future programs that reuse this technology. And it all continues to evolve, offering even more future value. Thank you for taking the time to watch this presentation. At this point, I'd like to open it up for any questions that you may have.
Thank you, Mr. John, for sharing how to overcome the real-time issues in today's session. We request all the delegates to drop your questions in the chat box now so that we resolve your queries. For further updates and to know more on the technology and usage of the tool, you can write to us at support@menloparktech.com or marketing@menloparktech.com. Thank you.